All right, so you guys do want to be opening your book here for a second. So we're going to look at the laws of logarithms. And I'd open up to about page 287. I've got some things that are highlighted here. You're going to find them in bold print on page 287. As we begin to look at logs, one of the things that we want to look for is if we're adding or subtracting logs, the first thing we want to look is see if the logs are all in the same base. So this question up here, the base that they all have in common is base 6, right? All right, because they're all in base 6, as soon as I can move the coefficient to that log out from it, I can factor out that log, okay? So that's one of the things I want to do. But whenever I factor out the log, what these rules are going to tell you is that where I see addition between logs, all right, as I factor out the log, that now becomes multiplication. And where I see subtraction, that becomes division, okay? So if I can factor out a log, the only way I can do that is if everything has the same base. Then addition becomes multiplication, subtraction becomes division. Can we remember that? All right, so you'll see that about 2/3 of the way down in your book on page 287, where it says this rule tells us that if we encounter an expression that contains the sum of two logarithms, we know that the arguments are multiplied. Okay, flip the page over to 288. It shows you, it says this rule, this is about 1/3 of the way down. This rule tells us that if an expression is the difference of two logs, then we know that the arguments are divided. Okay? And then finally down at the bottom, it shows you another rule. It says this rule is probably the most useful of the three rules and is the most difficult to remember. This rule is used two different ways, and we can use to turn an exponent into a coefficient. Basically what they're saying is that 4 is going to become the exponent to u in this question that you see up here. And the same way it can become an exponent to u, if there was an exponent there, we can move it out and make it a coefficient to a log. Okay? And you see that at the bottom of the page of page 288. Log base b x to the 5th is the same as 5 log base b to the x, or vice versa. 5 log base bx is the same as log base bx to the 5th. So if we understand those things, we're in pretty good shape. What's that? Yeah. All right. Let me see which of these I'm looking at here. Okay. All right. So what I'm going to do here is I'm going to go on to another page. This is it's a lot of writing. It looks difficult. It's not as bad as it appears, but if you're not used to it, okay. All right. So I believe as this starts off, I'm just going to start with what it says. We'll rewrite the question. All right. We have negative log base 6 u plus 6. Okay, plus 4 log base 6 u plus log base 6 u squared minus 36 minus log base 6 u squared plus 36. Okay. All right. Our first step in this, we're going to do a couple of things at once. Okay. We're going to take this 4 and we're going to make it an exponent to u. Right? Okay. The next thing I want to do is I'm going to take this and I'm going to factor it. Okay, because I have a variable squared minus a perfect square. That tells me I can split that up. Does that make sense? So as I rewrite this, let's see if I got this right. Our next step is negative log base 6. We still have u plus 6, so nothing has changed there. This becomes log base 6 u to the 4th. Okay, plus log base 6 u minus 6 plus log base 6 u plus 6. Okay. And what we can do, let's see, I don't know if it ends up staying that way or not. Is this different than what I'm seeing? Okay, this is, now I've written it down. Yeah, but let me, it's 6u, right? Okay, so not 36, it's 6u. Okay, my bad. All right, so this should say 6u. So what you can do with this is you can write log base 6 and then pull out a u and get u plus 6 in there. I know I'm running out of page there. Yep, need a bigger smartboard, or I need to start smushing it over on the left a little bit. Okay? Are you with me so far, though? We get some of these steps? Okay? All we've done so far is move the 4 as an exponent, split u squared minus 36 into u minus 6u plus 6, and factored out a u from u squared plus 6u. That's all we've done. Okay? So far, nothing terribly confusing. Okay? At least I don't think so. And because this is all addition, subtraction, it's commutative, so we can move some things around. Okay? So we're going to do that here first. We're going to move this over to the front. Okay? So we're going to have log base 6u to the 4th sit right there. And notice I got this negative log base 6 u plus 6. And I have a positive log base 6 u plus 6. What do we think happens with those? They cancel. Okay? So I could go through all of that, but that's what's going to happen with those two things, is that they're going to cancel out. Okay? What we still have, though, is plus log base 6 u minus 6. Okay, let's see, what did we cancel out? Here we canceled out this and this, right? Okay? Yes? Okay, all right, make sure I haven't messed up yet. Minus log base 6 u times u plus 6. All right, so as we rewrite some things, okay, we have log base 6 u to the 4th plus log base 6 u minus 6 and minus log base 6 u times u plus 6. Here, can I cancel out this last one and this one? No. No, not yet. But at this point, what we want to do is we've got this simplified down as far as we can get it. Okay? So we're going to cancel out, or sorry, we're going to factor out. And what we want to notice when we do that is that this is going to become multiplication, and this is going to become division. Okay, do we understand that so far? All right, so what I'm going to get out here is I'm factoring out log base 6. On the top of the division bar, I'm getting u to the 4th times u minus 6.
So why would they become multiplication and division?
Because they do. I could explain it, but it's going to go over your head. It's easier if I'm just telling. Okay. All right, the division is u times u plus 6. Okay?
How you can cancel?
Well, no, they don't necessarily cancel. If they had been u minus 6 over u minus 6, they would cancel, right? So let's go ahead and do this. We've still got log base 6 let's go ahead and distribute. You know, that's going to give me what, u to the fifth
Minus 6.
minus 6u to the fourth, right?
Yep.
Okay. All over u squared plus 6u. Okay, does that make sense? All right, finally, we want to look at what can factor out of all of it. What can I take out of every single term? 1u, right? So my final answer should be log base 6 u to the fourth minus 6u to the third over u plus 6.
All over you.
Okay, this is my answer.
So since you factored out that u, what do we do with the other u? Take out.
It's gone. Factored out. It's gone. Because it was in everything it factored out. Okay? Imagine it like this, you know, I mean, it's just a simplification. So, I mean, we could say 4/6, or I could factor out a 2 from the 4 and the 6 and say 2/3. Is 4/6 the same as 2/3? Well, what happened to the 2? It's not necessary, right? We've simplified it. That's all that's happened here. Use that extra u is not necessary. Okay? Did I go through that slow enough that we understood the steps involved? No? Do I need to go back through it again real quick? All right.
Since it's small.
It is smaller. Okay, question number 2. All right. Let me know if this is not the same question as what you see on your paper, because I have 2 different things here. Should be log base 3 x plus 4, okay, minus log base 3 x equals 4. I cannot, at this point, factor out the log base 3. And the reason why is because this 4 over here is not in base 3. Okay? I have to get it into base 3. Okay? So, in order to do that, okay, this is what I want you to understand. Let's take something simple like log base 3, 4. Okay? Now, in your older calculators, you don't have a log base function in your calculator. So what you have to do is log base 4 divide by, sorry, not log base 4, but log 4 divided by log 3. Okay? Does that make sense? Okay? Now what has happened is notice that there's no base underneath either of these logs. What we've done is we've taken both of these things and put them into base 10. Okay? So now they're both in the same base. All right, so we're going to do that same thing with this up here. Okay? Is we're going to rewrite this as log base 10 x plus 4 over log base 10 3. Okay? Minus log base 10 x over log base 10 3 equals 4. Okay? So what that allows me to do is notice I have 2 fractions here that have the same denominator. Right? So I could rewrite that as log base x plus 4, sorry, log base 10x plus 4 minus log base 10x all over log base 10 3 equals 4. All right? Now, I can move that log base 3. How do I move it? I multiply it. Okay, so I multiply both sides by log base 3 and not log base 3, but log base 10 3. Okay, that cancels out this log, and this log. And so what I get is log base 10 x plus 4 minus log base 10 x equals, and what we're going to go ahead and do is we're going to move that to the exponent. Okay, so we have log base 10 3 to the 4th. Have I done anything there? Have I lost you? Okay, now, is everything in the same base now? What base is everything in? Everything is in base 10, which means I can drop the logs. Okay? So, what does this subtraction become whenever I do that, though? Becomes division. So I wind up with x plus 4 over x equals what? What does it equal on the other side? 3 to the 4th. I can go ahead and simplify 3 to the 4th. Is that like 81? All right. So that's 81. Now I want to solve for x. So how do I do that? Multiply it by? I got to multiply by x and x to get this x out of the denominator position. That's giving me x plus 4 equals 81x, right? Okay, what's the next move? Subtract x from both sides, okay, or subtract 1x from both sides, either way. So I'm getting 4 equals what? 80x. Now what do I do? Divide by 80. Okay, what's 4 divided by 80?
120.
That's my answer. But you had to understand some principles to it. Okay? Do we understand what we're doing? So I'm trying to go through this slowly.
Okay, so subtraction turns into division.
When you're able to drop the bases, but I cannot drop the bases until everything, even the side of the equation, is all in the same base. Okay, so that's why we split this. Common denominator, right? I got everything in the base 10 that way. Okay? All right, let's look at the next one. All right. We have log base 90, 5 plus log base 93 equals log base 94 plus x. This is way easier than either of the two that we've done before. Because everything has the same base, what can I go ahead and do? What? I can multiply. What am I multiplying?
Can't you get rid of your logs?
Yes, I can. Yes, but whenever I do, it's 5 times 3 equals what?
4 plus x.
4 plus x. Okay, 5 times 3 is 15 equals 4 plus x.
4,
Subtract 4 from both sides.
11.
11 equals x. X equals 11. Right? Those are the kind that we want to see. Right? Those are the kinds of problems we want to do because they're quick and easy. Everything is in the same base. Make sure, though, that you change the sign because you know how many people leave the plus and do 5 plus 3 equals 4 plus x? A lot of people. All right. Next, we have 4. Let's see. Let's log base b x equals log base b 16. Okay, what do I have to do first?
Can you put the
That's 16.
4 as an exponent?
I need to make the 4 an exponent. 2x. Okay? So if I'm just rewriting, I've got log base b x to the 4th equals log base b 16.
Can you cancel out your
Now I can cancel out the logs. What am I left with?
x? 16.
X to the 4th equals 16. Well, what you could easily do is do the 4th root Find the fourth root of 16. 2. Okay? All right. Let's move on with this here a little bit. Let's see, what's next? Simplify. All right, we've got log base 7, 7 to the 6th, plus log base 3, 3, 3, minus log base 6, 6. Okay, now, let's, here for a second, look at a couple of different principles. One, if I just had log base 7, 7, okay? In fact, if I had any value where the base is the same as the number, keep in mind that that is the same as log base 7 over log base 7. So what would this equal? 1. The same way this would equal 1. So what you want to be able to look at, well, no, because we have these exponents, right? What should I do with these exponents, though? Where should they go? They go back in front. Okay, now, what happens is I have 6 times 1, right, plus 3 times 1 minus 3 times 1. Okay? All right, except what's interesting is in this case, addition doesn't become multiplication, subtraction doesn't become division. Right, because they're not the same base. Okay, so my final answer here is 6, because 3 minus 3 is 0. Okay, so anytime these numbers are the same, right, you're only looking at the exponent numbers and adding and subtracting those. Okay, so again, this is a list of really nice questions that I want to see, right? I want to see these in my homework. I want to see these on tests. Okay. All right, this one wants us to solve for x. We have log base 5, x plus 4, minus log base 5, x minus 4, okay. 5 to the 5. Okay, now before you get real quick to turn log base 5 to the 5th into 1, we don't necessarily want to do that, okay? Because I want to cancel out my logs, and as I cancel out logs, this stays 5, okay? Now what happens here? Division with the subtraction. So I have x plus 4 divided by equals 5. Good, okay? Now what? Times x minus 4 times x minus 4. Okay, that cancels out. Over here, I get x plus 4 equals what? 5x minus 20 is correct. Subtract 4 from 20. Okay. All right. All right, so you're getting x equals 5x minus 24. Subtract 5x. So you're getting what? Negative 4x equals negative 24. X equals 6. Are we feeling a little bit better about these than when we first started? Yeah. Okay. Some of these are a little... That first one, yeah, they start you off with the first one. You're like, oh my goodness. We're not going to do number 7. We're just, you're not going to find anything in your book or on a test that's going to look like number 7, so I'm not going to waste our very valuable and precious time with it. So Let's see if I can find what I want for number 8. Okay. Okay. Number 8. We have log base c 4x plus 6 log base c x minus log base c. Is that a y? Is that the same thing that you guys have got, or can you read it? That's what you guys have got. Okay. So what we're going to do is, let's see if I show this all correctly. We're going to represent this 6 out over here. Okay. That's going to give me x divided by y to the 6th. So what I'm winding up with is 4x times x to the 6th over y to the 6th. So 4x to the 6th 4x times x to the 6th is 4x to the 7th over y to the 6th, and you're going to keep your log base c out here that we factored out. Questions, comments, concerns about that? Do we understand it? Okay. All right. Number 9. Number 9 is exactly the same as number 1.
Oh, we can skip it.
I'll tell you that the answer is A, and if you find time, work it out. Finally, though, we do need to look at number 10, okay? Because it says, show that f and g are inverse functions or state that they are not. All right, so they tell me that f of x, this is the same as the question you guys had in your homework where we had to reduce down to x to determine if they are inverses. Okay, so we have something like that. Let's see if I have my work for number 10. So for this first one, we have negative 6 and a big set of parentheses as we get negative x plus 3 over 6 minus 3. That negative 6 distributes, so I end up with 6x minus 18 over 6 minus 3. This whole thing divides down to be, x minus 3, so I get x minus 6. I can stop right there because this did not reduce down to just x. I know that these two things are not inverses of each other. Okay? Now, if I had gotten x here, I would still need to plug f of x, all of this, into that x spot right there and see, does it equal x whenever I plug f into g? Okay, if it does, then these two things are inverses of each other. Does that make sense? Okay, all right, we'll stop right there. Hopefully, you guys learned enough about the log stuff to be effective on your homework.